Yeah, so thank you very much for the organisers for the invitation and for the nice introduction. And that was a really great, talk to proceed.
And let me just really quick. Can I just really quick remind everybody? Let's try to stay on time as much as possible so that we don't run too much over. Yeah, please.
Okay, thanks. I'll try to keep it short. Okay, yeah. So that was a really nice talk to introduce the problem that I want to discuss here, which is, so in the previous talk, we heard a lot about, searching on BioPortal, for example, and finding lots of different ontologies hitting the same term. So, we need to be able to deal with mappings and, map between, if you've got data in one, data curated with one ontology and you want to map it to another in order to cross-integrate, we need to be able to do this accurately. The proliferation to some extent of ontologies is inevitable, or, but how can we actually do this effectively? So at the EBI, we run an ontology mapping service called OXO, which incorporates mappings from all sorts of different sources and has a pretty nice interface for and an API for uploading sets of terms and trying to map between ontologies of choice or finding what mappings are available. But obviously, it's only as good as the underlying data. So right now, it mostly runs on cross-references between ontologies and UMLS. There are a few other mappings that it incorporates, but we can incorporate, whatever is available. The basic problem, so as previously discussed, there's a huge, not only is there a proliferation of ontologies, there's a proliferation of mappings, often conflicting with each other, frequently stale, sometimes pointing to obsolete terms, for example. The semantics very often in mappings are unclear. Do they mean the two terms are equivalent, exact, related in some ways? Occasionally these mappings are between terms that are in completely different domains, like disease and anatomy, for example. And the mappings typically they don't follow sort of fair standards unless to some extent they follow them because they're incorporated in an ontology which tries to. So given these issues, how can a user of a mapping service like OXO achieve an accurate set of mappings? One other use case I want to talk about here, the International Mouse Phenotyping Consortium wants to be able to map between annotations to a mouse phenotype ontology, because they have a huge database of mouse phenotypes from a massive knockouts program. But they want to be able to search using relevant clinical phenotype terms. So that requires mapping between their mammalian phenotype ontology and a clinical phenotype ontology like HPO. In this case, so the work of the MOIC initiative that I'm a part of, one of our projects is this Unified Phenotype Ontology, where brings together a whole community of different phenotype ontologies, you can see on the left. So it's providing a lot of mappings where a lot of these are kind of cross-species mappings, not exact. What we do is work on coming up with standardized templates to define terms, and that then that gives us close semantic similarity, so we can map between phenotype ontologies. So in this example, mapping zebrafish enlarged heart onto human enlarged heart. Going back to this hyperchloriduria example, example. So here's the term in HP, and here's the term. So with typically Latin medical name, and here's the term in the mouse phenotype ontology, and you can see we've aligned these formal definitions, and that allows us to get a high semantic similarity score to link these two. So if you want to hear more about this, there's actually a talk later in this meeting from Nicole Vasilevsky and Sue Bello on the uPheno project itself. Okay, the disease ontology space, in that case, we were talking about, there isn't too much of a proliferation of phenotype ontologies, at least except in terms of different species, although I guess there's a lot of overlap with, I think, something like HPO in the clinical vocabulary space. Here's some work done by Melissa, who'll be talking later in the keynote, to make and others to make a census of disease ontologies. And in this, this identified 37 different partially overlapping disease ontologies, vocabularies. And just to show one example of this, one issue here, that many diseases are only in one of the sources, and there's only a fraction for which the same disease concept occurs across all resources. But again, many of the mappings between these things are unclear. We have, so as I said before, with this proliferation of mappings, often conflicting and the semantics are unclear, there's two ways you might want to approach this. One is, generate some kind of merged ontology out of all the different, out of all these different ontologies, so you have full coverage. Another would be maybe to try and leverage all of this to try and get a really accurate set of mappings. And actually, what the work of the Monaco Initiative on the Mondo disease ontology has done is try to combine those two. And they've used this approach of Bayesian OWL ontology merging. So whenever you merge, so you have this hairball of links between different mappings between different ontologies, often at different levels of precision. So you might have one mapping that goes from a specific to a general term, and another mapping that goes from another general term down to another specific term, and these things cross, and you end up with these tangles. So here's an example from NCIT, which has now been fixed in discussion with NCIT, where neuropathy and peripheral neuropathy really kind of had the same definition. They were referring to the same concept. I won't go into the details here, but this K-boom system provides a semi-automated process for avoiding this. So first of all, there's a step that generates the merged ontology structure using logical and probabilistic inference over weighted mappings, and those weightings come from a variety of different sources, including lexical similarity scores and lots of other things. And then there's a curation cycle which tries to resolve any cycles which remain. And that, I think there's an important point here, that you can never get all of the way with some entirely mechanical process. There needs to be at some point where there are clear conflicts or cycles for human curator intervention. So that's what was done in generating Mondo. Here's a list of all the different disease ontologies that went into that process. And Mondo is now, a curated ontology as well. And here's a very quick example of the resolution. So you can see in the dotted arrows, the dotted lines here above are the sort of tangle of the hairball tangle of mappings between different levels of the ontology that came from cross-references in these different ontologies, and here's a resolution. The important thing is, so here's the resolution of that in the Mondo disease ontology, but also out of that comes a set of cross-references, and you can see in this case, these mappings, when they have equivalent to, because they've been through this process, these have a high, we have a high confidence that these are exact or close to exact mappings, whereas other mappings don't get that tag, so we have less confidence in them. Actually, there's ongoing work on this algorithm, and Jim Balhoff is giving a talk later on in this meeting on the Boomer, which is the sort of next generation version of K-boom, which has been applied to a lot of other ontology merge and mapping situations. So I said earlier that one of the problems with mappings is there isn't actually, for all that they come out of standardization efforts, there hasn't to now been a really good standard for actually recording ontology mappings themselves and their metadata for making those mappings fair. So fair, providing licenses and good provenance information, but also, reusing a vocabulary which allows the meanings of those mappings to be clear and shared. Nico Watenzoglu, who's part of my group, well, is now actually a contractor working with our group, has developed this simple standard for sharing ontology mappings. So it includes a record of the predicate that links the two, a subject that links two sides of the mapping. It includes information about match type as well as provenance. It also includes a confidence score as well. And that's being used. Nico is spearheading efforts to generate a set of mapping commons. Actually, some of these are Nico's work and some of these are other people's work who've brought into this to generate a set of mapping commons where there are big repositories of these mappings for people to reuse. So I seem to be doing a lot of advertising of other talks there, and Nico will be talking a bit later about some. So OXO right now, here's a set of results, and you can see actually, so this was just a one hop from, two hops from Mondo neuropathy, and you can see the various problems here in the underlying mapping data. Here's a map to an obsolete term. Here's a mapping to a more general term, just peripheral nervous system disease. And then here are a couple of OMIM mappings to more specific terms. So, you know, without any, this is a really nice example of obsolete, and then also not the, not providing details of whether this exact broad or narrow as a mapping. And here's a mock-up. So we do have, we've got ongoing work to incorporate the SOM model into the OXO data structure, and that's the first round of that is pretty much complete right now. So we have it in the underlying database, and now we're starting the work on exposing this through the UI and the API. So here you can just see a few examples that come from exact mappings actually from the Mondo work. I think I'm missing a column here. Actually, it should have a column that shows the source. Oops. Sorry, what happened there? Here we go. So now, you know, we have for two of these cases that we have curation of an equivalent or exact match. We have a confidence score, and we have a match type. Now you can see, so users can sort on these. They can set cutoffs through the API, and the plan for the confidence right now is it's an aggregate of provider confidence, user confidence, which can come from voting, and then a trust factor, which comes from the API, which is partly comes from the predicates used. And then if there's a two hop distance in mapping, so this allows for transitive, this allows for hopping across more than one mapping, then we choose the minimum confidence in the chain plus a penalty. So this is kind of, you know, the precise details are still under discussion, but at least I think this gives a clear way to start being able to access and get some sense of what mappings mean and get accurate sets out of using a tool like OXO. And underlying this is a mapping commons underneath the ontology lookup service. So it'll include the mappings that come from Mondo. So in these cases where we're mapping through a single ontology, we can actually collapse down into single step links. It will include mappings from the phenotype ontology. So that the plan is right now, IMPC in the example I showed earlier is using kind of opaque and slightly old set of mappings and system for generating those. And we're working with them to move over so they can use OXO and the mappings that come through uPheno and other trusted sources via OXO. And we're very keen to get, I know there's a big community here of people building ontology mapping tools. And I'm sure we're going to hear lots of interesting talks about those. So we're very keen to get mappings contributed to this OLS Mapping Commons so that we can start untangling this hairball together. So And then, yeah, just to acknowledge, this is the work of a lot of this is the work of the Monarch Initiative, but in collaboration with developers at the EBI. Thank you very much.
David,
any questions?
Yeah, thank you, David. That's really cool work, and right at the heart of the problem, like so amazing. So just as a reminder, everybody can type in questions into the chat, or you can raise your hand, and then I think Samantha can probably see better who would be raising their hands. We're almost out of time, but I was just wondering, David, like, not being an expert in this ontology mapping technology, but would you say, like, is this K-boom and then the next version Boomer, is just like how generally applicable do you think it is? Like, I mean, for uPheno, right? There are for the phenotype ontologies, they're kind of had already like it's some kind of like little bit related structure, right? And that allowed mappings based on their kind of semantics. Right? So if you now have sources where maybe there are partial overlaps, right, or terms overlap in some way, and then they're in a completely different structure, would it still be applicable? Would it still be usable in some way?
So I think this is, I'm conscious that I'm presenting a lot of other people's work in this talk. It's kind of a synthesizing of work talk. So I don't know if Jim Balhoff is on. He might be better, or Chris Mungle might be better placed to answer the question. It's more their work. Yeah,
I'm here. Yep. So I'll have a little bit more detail about Boomer tomorrow. But it just uses the mappings primarily, and it takes into account the structure of the ontologies, but you don't have to have any structure. They don't need to share any semantics to two ontologies. You could just feed in a bunch of mappings if you want.
So use the input that can be from textual mappings or manual mappings, and then you just basically resolve the conflicts. Yeah.
Yes.
Yeah, I get it. Yeah. Oh, that's very cool. Okay.